All right, so problem number 11. Find the circumference and area of the circle. Round answers to the nearest tenth. One thing I will make note of is that I am not giving you the formulas for circumference and for area. So if you want those formulas, they need to be on your cheat sheet. Circumference formula is 2 pi r. Area formula is pi r squared. R is the radius, which is the distance from the center to the edge. Since we're going to be finding distance, I need my distance formula. This is another one that if you want the distance formula on the test, it's got to be on your cheat sheet. Distance formula, we take our x's and subtract them. x2 minus x1, close the parentheses and square it. Plus, then we do the same thing to our y's. y2 minus y1, close parentheses and square it. Then after you do both of those, you subtract your x's, you square them. You subtract your y's, you square them. You add them together. And then at the very end, you take the square root of the whole thing. Please make sure as you're working through this problem that you continue to write the square root symbol over until the very, very bitter end, because you need to do the square root at the end. All right, so we have the center right here. And we have a point that is on this circle, point B. So this distance right here is our radius. So we're going to go from point A to point B. I'm going to pick one of my points to be point 1. Let's go with, I don't know, point A. So that would be my x1 and my y1. And then I'm going to go with point B to be my x2, y2. It does not matter if you flip it around the other way. Just make sure that inside one set of parentheses you have an x and a y. It's not x1, x2. It's x1, y1, x2, y2. All right, so I'm going to subtract my x's. x2 is 2. So I have 2 minus my x1, which is 5. That goes inside parentheses and gets squared. Plus, then we do the same thing with the y's. My y2 is 1 minus my x2, which is 3. Close my parentheses and square that. And then we put the square root around the whole thing. All right, so now I'm going to simplify my parentheses. 2 minus 5. What's 2 minus 5? -3. So I have -3. Please do not drop the parentheses. They are really important if you plan on using your calculator. And then inside the other parentheses, I have 1 minus 3, which is... How much is 1 minus 3? -2. Close the parentheses and square it. Those parentheses are really important because if you're going to stick this in your calculator, if you don't put the parentheses around it, it will lie to you and give you the wrong answer. You've got to put the parentheses around it when you put it in the calculator. Or this is one that you could do without the calculator. Because what does it mean to square something? Multiply it by itself. So I'm going to have a -3 times another -3. Well, I know a negative times a negative gives me a positive. So what is -3 squared? 9. Plus, what about -2 squared? 4. Underneath my square root. And then I add the 9 and the 4 together and I get 13. So here's my radius, my distance from A to B. We're going to use that in those two formulas. So for my circumference, I do 2 pi, and then inside parentheses, square root of 13. And I pop it into my calculator. We have a pi button on the calculator. Don't use 3.14. The calculator is more precise, and plus it's just one button push. Use the pi button on the calculator. When you do that, you should get something that is right about 22.657. If you're going to round that to the nearest tenth, that's 1 decimal place. So I'm going to round to just 1 decimal place, which means right here. So I look at the number that is right after it. It's a 5. That means I'm going to round up. So I would say 22.7 for my final answer here. On the answer key, I did go ahead and write out 3 decimal places so that as you guys are doing it on your own, you see what the calculator is showing or something much more closely related to it. On the test, if it says round to the nearest tenth and you give me 3 decimal places, we're fine. I'm never going to complain about more decimal places. Area. Area is equal to pi. And then inside parentheses, I would have the square root of 13. And then that gets squared. And that one comes out to be about 40.851. So again, here's where I'm rounding to. I look at the one next to it. Anything that's bigger than a 4 means I round up. So 5 is bigger than 4. So I would say 40.9. What else do you guys want to see? Number 12? Absolutely. Yes. Does anybody need me to leave this up for a little bit longer? Okay, number 12. Given the following conditional statement, write the converse, inverse, and contrapositive. Then determine if each statement is true or false. If false, provide a counterexample. If it's true, we don't have to provide a counterexample. In fact, a counterexample does not exist if it's true. So to do the converse, we're going to switch the hypothesis and the conclusion. So let's look at our conditional statement. Everything that comes after the if, up until that comma, this is my hypothesis. And then everything that comes after then and runs to the end of the sentence is the conclusion. So to write my converse, I need to switch that around. The if still goes to the beginning. It's just the stuff that comes after the if all the way up to the comma that's going to switch. So if I just rewrite what it says if their measures are equal, what does it mean by that pronoun? What is there? Not necessarily vertical angles, but what's at the beginning of the sentence right after the if? 2 angles. So instead of writing there, I'm going to replace that with what there is meaning. So if 2 angles measures are equal, comma, then, and now I can rewrite that hypothesis. Two angles are vertical angles, or I could say they are vertical angles. All right, so let's read that one. If two angles' measures are equal, then they are vertical angles. You could even read that as then they have to be. If two angles have the same measurements, do they have to be vertical angles? No, so I would say this is false. If I say it's false, I have to provide a counterexample to this. Dalen, you with me? Doing okay? So I'm going to draw a picture that's two angles that are the same size, but they are not vertical angles. Are those angles that I just drew vertical angles? Nope, they're not even touching. I'm going to say this one over here is 30 degrees, and I'm going to say that this one over here is also 30 degrees. They're not vertical angles, but they do have the same size. Before we go on and we do the inverse, I want to ask about the truth of the original statement. If two angles are vertical angles, then their measures are equal. Is that something that is always true? If I have vertical angles, are they always going to be the same size? Are vertical angles always the same size? Yes, vertical angles are congruent, so vertical angles are always the same size. Our original conditional statement is true, but the converse is not true. All right, to write the inverse, we leave it in its same order, but we put not, and then our hypothesis, and then we put not, and our conclusion. So instead of if two angles are vertical angles, we're going to say if two angles are not vertical angles. And I have to put a not with my conclusion also. So instead of then their measures are equal, I'm going to say then their measures are not equal. Ran out of room on my line, so I dropped it down just a little bit. So let's think about this. If two angles are not vertical angles, okay, then their measures can never be equal. Is that true? If they're not vertical angles, does that mean they can never be equal? No. So we would say this is false. For a counterexample, I need to either explain or show two angles that aren't vertical but do have the same size. So I can recycle the picture that I used up above. These two angles here are not vertical angles, but they are the same size. Or I could come up with a different picture if I wanted to. For the contrapositive, we do both what we do in the inverse and what we do in the converse. So it's going to be not, and then my conclusion, not, and my hypothesis. So basically, I'm going to come up to the converse, and I'm going to put nots in here. That would make my converse. If two angle measures are not equal, then they are not vertical angles. What do we think? If we have two angles, and I know how big each of them is, and it's not the same, their measurements are different, is it possible that they are vertical angles? What do we know about vertical angles? Vertical angles always have to be the same size. So if I have two angles that aren't the same size, can they be vertical angles? No. So this statement is true. All vertical angles are congruent to each other. Is it possible to write a biconditional for the conditional? A biconditional statement is going to have the hypothesis, and then it will have the words if and only if, and then it's going to have the conclusion. It will not have an if in front of the hypothesis. So instead of saying if two angles are vertical angles, I would just say two angles are vertical angles. And then I would put in the if and only if, and then I would have my conclusion, but it would not have a then with it. So a biconditional statement, I'm not going to have the if and the then. Separating my hypothesis and my conclusion is going to be the words if and only if. Is it possible to do this? In order to write a biconditional, both the conditional and the converse must be true. Is my original conditional statement true? Yes. Is the converse true? Can I write a biconditional? No. No, it is not possible to write a biconditional. Because, why? Why can't I write that biconditional? Because the converse is not true. If the converse was true, then I could write it. And if I could write it, here's what it would sound like. Two angles are vertical angles if and only if their measures are equal. That means it goes both directions. The only way I can have vertical angles is if their measures are equal, and the only way I can have two measures of angles are equal is if they're vertical angles. That's what a biconditional says. We have it one direction, but we don't have it the other direction. The converse is not true. What else would you guys like to see? I have time for one or two more, depending on the length. Yes. Number 18, absolutely. Number 18, first thing I notice on number 18 is that there's an angle that has x in it here and there's an angle that has x in it here. These two angles are in matching corners. They are lower right-hand corner, lower right-hand corner. We call these corresponding angles. And what do we know about corresponding angles? What's the relationship between our corresponding angles? Complementary, supplementary, congruent. What's the relationship on corresponding angles? Congruent. And what can I do with things that are congruent? Set them equal to each other, absolutely. So I would have 10x is equal to 2x plus 80. Thank you. And now we're going to solve this for x. So I'm going to subtract 2x from both sides. Yes, you may. I get 8x equals 80. Divide both sides by 8. I get that x is 10. So there's one of my variables. But this other angle over here has a y in it, so I need to find y also. Luckily, I know a relationship between these two angles. What do we call angles that form a pair like that? A linear pair. And what's the relationship between linear pair angles? Supplementary, they add up to 180. So I'm going to take those two angles, y plus 3 plus 2x plus 80. And I'm going to set that equal to 180. And we just figured out that x is how big? X is 10, so 2 times 10 plus 80. Two times 10 is 20, so I have y plus 3 plus 20 plus 80 equals 180. What do I get when I combine my constants together, the 3, 20, and 80? $103. So y plus 103 equals 180. Then I subtract 103 from both sides. I get y equals 77. Part B, we need to solve for our variables. How many variables are there in part B? 2. We've got x and y. There's an x here and an x here. These two angles right here form a special pair. What do I call those two angles that both have the x in it? What do I call that pair? Alternate exterior angles. What's the relationship between alternate exterior angles? Congruent. Opposite sides of the transversal are congruent. And with congruent things, I can set them equal. So 7x minus 4 equals 6x plus 2. Got to get my x's to the same side, so I subtract 6x from both sides. 7x minus 6x gives me 1x, so 1x minus 4 equals 2. And then I add 4 to both sides. X is 6. And then I'm supposed to find y. Well, y is right here. What do we call this pair of angles? Vertical angles. What's the relationship between vertical angles? Congruent. So that means I can take them and set them equal. So 7x minus 4 equals 2y plus 6. And we just figured out that x is how big? 6. So 7 times 6 minus 4 equals 2y plus 6. What is 7 times 6? And 42 minus 4? 38. So 38 equals 2y plus 6. Subtract 6 from both sides, absolutely. What is 38 minus 6? 32. 32 equals 2y. Divide both sides by 2. Y is 16. I think I have just enough time to do a short one. Thank you. Does anybody have a short one they want to go over? 23? Absolutely. Let's go look at 23. Yep, that's a nice short one. Perfect. Which figure in the diagram is a rotation of figure 2? So let's look at figure 2. Stem is pointing down. Leaf is right here. There we go. So a rotation of that particular shape would have to look either like this, or like this. Are there any of those oranges that look like one of those 3 pieces when I rotated it? 5. 5 looks exactly like that rotation. Any others? Are there any others that look like this right here? 4. So 5 and 4 would both be rotations. A translation is a slide. So we want a translation of figure 3. Here's figure 3. Translation has got to be a slide. It doesn't match figure 2. It does match figure 1. Doesn't match figure 5. Doesn't match figure 4. So figure 1 would be a translation of figure 3. And then a reflection. This is like a flip. Which one looks like a reflection of figure 5? Like a mirror image. Which one? 2? 2 is not a reflection. Figure 1 is. So the problem with figure 2 is if I take figure 5 and I flip it upside down, the leaf is still going to be on the left-hand side. And when I look at figure 2, the leaf is not on the left-hand side if I just flip it upside down. If I flip it horizontally or across that horizontal axis, the leaf is going to go from the left to the right, but it's still going to be a face-up orange. Like the stem is still going to be coming out the top. So that's why figure 1 is a reflection, but figure 2 is not. Does that make a little bit of sense? Yes. So figure 3 is a reflection and a translation put together. So it does look the same way that a reflection would look, but there's no single line that I could fold figure 5 over and make it land exactly on 3. Does that make sense? With a reflection, you should be able to find a line somewhere that you could fold your paper on, and it would match up like a mirror image there. I am wrapping it up a little bit before the bell because I wanted a chance to pass back your test from last week so you guys can see that last test. I do have to recollect these, so please do not put them away in your bags.